In this video session, we're going to be going over the FeatureCAM part library and how you can use it to make your programming quicker, more consistent, and more automatic. So here's the agenda we're going to cover in this session. What is the part library and what can you do with it? Creating features for the part library and some strategies for doing that so that you have the most versatility possible. And then once those features are in the part library, we'll talk about bringing those into new files, either as is or into new locations, maybe as parts of a pattern or applying features to new curves. The next topic we'll cover is applying attributes of part library features. So instead of bringing a part library feature into a file intact, we're gathering its method. So we're going to capture the way that feature was programmed, the way the toolpath is designed, and apply it to a new feature. And then finally, we'll talk about boosting the part library automation with the help of an add-in macro. So what is the part library? Well, it's simply a repository for storing FeatureCAM entities. In this session, we're talking primarily about features, but you can store any FeatureCAM entity, whether it's geometry or curves, surfaces or solids, or features. And then you can use those items in future parts. For example, the part library might include lines and arcs. Maybe you have a layout sketch in there that you use to position parts, but you can reuse that over and over again. You might have a special feature that you make repeatedly and you don't want to have to design from scratch every time, like a custom thread. Or you could have a single feature with customized attributes that you want to reuse as a method on other features. And it's important to mention that the part library works with any FeatureCAM module except Tombstone and Multi-Fixture. In those two modules, you really don't make features. You're just applying parts that have already been programmed. Okay, so let's get into the software. And I have an example here. I've made myself a little Autodesk logo, and I'll show you a 3D simulation. Okay, so it's a pocket with a chamfer and a groove in the bottom that I'm engraving with. So maybe this is something I want to include on many of my parts, and I don't want to have to create from scratch every time. So I want to point out a couple things about this. First of all, you'll notice that I made some tool overrides. So it's important to realize that those can follow through. So when I use this feature again, I'll get the same tools. I also positioned the original features at 0, 0, 0. This isn't required, but it's very helpful when it comes to placing the features in other files. Now I'm not quite ready to put this into the part library yet. You'll notice that I have two features. So as I mentioned, there's the pocket and the groove, and I want these to travel together all the time. So I want these to be considered a single unit. In order to do that, I have to make a quick group feature. So I'll make a group feature. I'm going to add in these two features. And I want to make sure they are indeed manufactured in this order. It's important that I don't try to engrave before that pocket exists. And now I have a single entity that I can put into the part library. Before I do that, there's one more good practice I want to share with you, and that is to give these descriptive names. If I put group 1 in the part library, next week I'm not going to remember what that is. So to make things much easier, I'm going to rename this Autodesk Logo 1. Okay, now we're finally ready to put this into the part library. So how do we get there? Well, there are a couple ways to do it directly from the interface that you see right now. I can go into the part view and double click part library. I can also go to the home tab of my ribbon, over to the clipboard group, and click part library there. Either way, I get to the part library, and what you see here is the part library that's installed with your software. So it's the default library in the default location in the program data folder. You can have many part libraries, so you could have part libraries for any purpose you want. You could have different modules like milling and turning, or you could have different users or different machines, however you want to organize your part libraries. And then within the part library, you can also organize into folders. So again, just further organizing your part libraries to make them as neat and logical as possible. These part libraries can exist either locally on your computer, or you can put them on a network, and everybody who's programming with FeatureCAM in your organization can draw from the same information. So I'm going to go with the standard part library. I'm going to take my logo, click the folder where I want it to go, and click Add Selected. And now that group is in my part library, and I can click OK, and it is put away. At this point, I really don't need this file anymore. I could delete it. It's not going to have any effect on the part library. The part library is not backward associative, or it doesn't have any dependent relation on the file. But I recommend you keep these files if you think you might make changes in the future, because I can change this file and then add the revised feature or group to the part library and then delete the old one. So however you want to manage this is fine. Okay, so now I'm going to apply my feature. I have another example here. It's simply an empty file, and I want to bring in my Autodesk logo. A couple ways I can do that. Since it is indeed a new feature, I could go to the new feature wizard, or I could go straight to the part library and paste it from there. It's really up to you. I'll demonstrate the new feature technique. You go under user defined and click next, and you'll see, in addition to some add-in macros that you might have enabled that define UDFs, you'll see your part library, whichever part library is active at the moment. Click the feature you want, click next, and at this point I only have a couple options. I can paste it in as is, or I can paste it into a new location. So if I just paste the feature in and click finish, you'll see that it goes in exactly as I defined it. It goes in right on the origin. I have my tool overrides and everything is exactly as I programmed it. It doesn't make a lot of sense to do that on this part, so let me undo that quickly. And I'll go back and paste it into a new location. That's the second option. The first thing it asks me is a reference location, and then my feature will be placed relative to that location. So I'll leave this at 0, 0, 0 and click next. And now it asks me where to place the feature, and this is where having created the original at the origin is helpful. I don't need to take into account any kind of original location when I place this. So in other words, if I want this to be at x3, y1, z0, then that's exactly where it goes. I don't have to add or subtract some original dimensions. Okay, click finish. Dismiss the part library interface, and I'll give you a quick 3D simulation. And again, it comes in exactly the way I programmed, with every override, every setting. I can also apply part library features to patterns. So I have a pattern under a layer here, just some points that I placed into the file. I'm going to select those and then go to new feature, select user, and notice how I'll make a pattern from this feature is already selected for me because it recognizes that I picked multiple points. Select my logo, and now I don't get the same options I had before because I've already told the feature what I want. I want a part library feature at every one of these positions. I can work with the sorting if I wish, tighten that up a little bit, maybe move everything around so I can go straight from my original to the pattern, and click finish. I get all of my logos on my part. All right, let's look at another example now. In this case, I'm not going to be pasting features in directly. I'm going to be pasting more of a method. So I'll come into this file here. I'm going to run this pocket in centerline simulation, and you can see that I'm using Vortex. So a couple things going on here. I've got the Vortex roughing toolpath. I have actually multiple rough diameters. If you look over in the operation list, you see a 1/2 inch end mill and a 3/16 end mill. And then it's finishing with the 3/16 on the walls. Now, there's some things I did when I designed this feature that I did intentionally to make it as versatile as possible. First of all, you'll notice that there are no overrides. I don't see any asterisks under tools, so these are the default tools based on my tool selection rules. You'll also notice that even though this is physically a pocket, I defined it as a side feature. A side feature gives me more versatility because I can cut the inside of a curve or the outside of a curve. I could even cut an open curve, but understand if you use an open curve with Vortex, you're going to get NT toolpath. But I'm talking about closed curves here. With my Vortex, I can go either way with a side feature. If I were to define this as a pocket, then I could only apply the pocket attributes to other pockets. So I would be limiting myself a little bit that way. Okay, so now that you understand what I was thinking here, I'll add this to the part library. put the side in the folder, add that selection, okay. And now let's apply it to another part. Okay, this part already has a feature programmed, this center pocket here. And you can see just standard spiral toolpath, a single tool, but I want to create this pocket using the stored process that I have. Now, I was thinking ahead. There's some strategy and some planning involved here. I defined it as a side feature, so that will give me the ability to paste side feature attributes to it. So I'm not going to new feature in this case because I already have the feature. I'll go straight to the part library. I'm going to select my vortex side and paste it in. And now I have a couple more options. I'm going to select option 3, copy the machining attributes from the selected feature to another feature. Now notice what I can select here. I want to paste in the machining attributes, obviously. I can go with all of the attributes or only the ones that I had set. And notice that if I had set tool or feed and speed overrides, I could choose whether to take them or ignore them at this point. This is dimmed out because I did not set those. So yes, you can ignore those overrides if you wish, but I think it's better and easier to just not set the overrides in the first place if you know you're putting this into the part library. Okay, so we're going to paste onto the side feature. We could put as many features, side features here as we wish. I'm going to hit finish. And now I have vortex toolpath. And because of the flexibility in my original part, it did not require multiple rough diameters. So it's still using that 15/16 end mill. I could make changes. If I want to use a 3/4 end mill, I can certainly change that. The changes do not flow back to the part library. There's no associativity there. So I can make whatever changes I want here and keep the part library feature intact. Another thing I can do, let's turn off that side feature and look at a different instance. I have a curve here and I want to cut the outside of the part using the same method. So I could go either way here. I could call that a new feature. I could go straight to the part library. It really makes no difference. But I'm going to paste this in. I'm going to paste that feature onto a new curve. I'll select the curve, hit next. You'll notice that it has the depth of the original feature here. So I will have to make a couple minor adjustments. I'll click finish and just change that depth. This should be 450. And since I'm in here, it's not a bad idea. It's a side feature, so I just want to make sure it's cutting the proper side of my profile, and it is indeed. So that's fine, and this is programmed. And while this is calculating, take a look at my tools. It's using a 1/2 inch end mill and a 3/8 end mill in this case. So the flexibility of the feature enables it to pick the appropriate tooling for this geometry. And this is all set, ready to go. Okay, let's look at another example. We're going to talk about surface milling now. It's done slightly differently. This part's already programmed as well with a single feature and a few different processes. So I'll show you a quick 3D simulation. I'm going to get some Z-level roughing with step milling. You can see that there. This is steep and shallow finishing, getting the whole part. And once this is complete, it's going to come back with some corner remachining with this tool here you see in yellow. And I'm happy with this, and this might be a method I want to use. Maybe I do parts like this or similar parts on a regular basis. So again, instead of having to start from scratch, I can just copy this method and apply it to a new part. So I'm going to bring out the part library. Yes, I should rename this, give it something more descriptive, but just for the sake of time in this demonstration, I'm going to add it straight in. I could always rename it later using this button right here, and I probably should. So now let's look at the next file. Let's suppose that at a time down the road, I receive this file, and I recognize that I could do this the same way I did that part library feature. Now, what I don't want to do in this case is just paste the part library feature in, because if I do that, it's going to bring in the original geometry as well. So whether it was surfaces or a solid, it's going to bring copies in. I'm going to have to take those out of the feature, add these faces into the feature. It's a little messy that way. This is a quicker way. I'm going to create a feature here in advance. And this feature is going to act as a placeholder or target. So all of the faces I want to use a single operation. I really don't care which one. I click Finish because again, this is just giving me something to paste to. I really don't want the parallel process, so I'm going to go and uncheck it. Just exclude it. I could delete it, but if I delete it and have no operations here, then I can't click OK and close the feature. So I'm going to keep it around. I can come back and delete it later, but I'm going to turn it off for now. Now I have a target onto which I can paste the attributes of that part library feature. So I'll go back to the part library, select the surface mill, which of course I should have renamed, and I'll paste it in, and I'm going to get the attributes. Notice how it gives me all of the processes, and I can pick and choose the ones I want, and then I can paste to this feature or multiple features. Finish, and now this part is programmed. Once the calculation is complete, you're going to see the Z-level rough with the step milling. You're going to see the steep and shallow finishing, and finally the corner remachining. So here's my step milling, steep and shallow, corner remachining, and minus any minor changes I want to make, this part's finished. Okay, for my last example, we're going to go into a turning application, and I'm going to show you how we can boost the effectiveness of the part library with the help of an add-in macro. So let's take a look at what I have here. Clearly this part's already programmed. Let's just get a general idea of how big this is. It's a metric file, 162 millimeter OD, 74 millimeter length, 55 millimeter ID. I'm just showing you this so we can see that the next part I bring in is clearly going to be a different part. It's a different size. But it's a pulley I have here, and maybe I do lots of pulleys in just different configurations. So I'll run a quick 3D simulation, I'll slow this down quite a bit. So we have turning, and then some grooves, boring, and then the face groove. And as I mentioned, I do lots of pulleys. So I do pretty much this process on all of my parts, just different sizes and shapes. So what I want to do is be able to capture this process and apply it automatically to my next part. All right, there's some groundwork to take care of first. First, you notice the features and you notice the naming convention here. We have op1, op2 through op5, underscore curve, underscore turn, or underscore T-groove, or bore. Okay, so that's a certain feature type. And if you look at the curves, they have the same naming convention. So curve underscore bore, curve underscore T-groove, etc. So the way the macro works, it's going to look into my next file where I'll pre-create the curves. It'll look for this naming convention, and whatever curves it sees, it will apply to the appropriate feature type. All right, so in order to do that, the features have to be in the part library. And I'm going to just switch my part library. Remember, I told you can have multiple part libraries where I've already stored these features. So again, what the macro is going to do, it's going to look for the curve. If it sees the appropriate suffix, it's going to go find the matching feature and apply it to that groove or that curve. All right, so let's go look at the next part now. Now we looked at the dimensions on the last part. I think it was 162 millimeters. So 142, a smaller length, the same ID. So clearly a different part with the same type features though. So everything's in place. I have my curve names ready to go. Notice the naming convention is correct. I'll go to my add-in tab, and setup curves is the add-in. I'll run the macro and simulate my part. And this part is finished. So we've taken the part library where we store things away, and we've completely automated it using an add-in macro. Actually, this part isn't quite finished. I have some holes drilled in that face, so I'll do a quick feature recognition of holes. And I'll take all of the holes except for the bore, finish, and now this part is complete. So just to recap, what we've done is we've discussed the part library, what it is and how you can use it. You need to be a little bit strategic when it comes to how you store away your features or whatever entity you put into the part library to make them as flexible as possible, but then you can bring them back and reuse them in a variety of ways. And it's going to make your programming a lot more consistent, a lot faster, and even potentially more automatic. And it's especially helpful if you have multiple programmers. You're not going to worry about one person's programming style versus another. You can put your part library on a network, everybody can program off it, and your operators will get very consistent results out at the machine. So hopefully this has inspired you to get your own part library set up so that you can streamline your programming in FeatureCAM. Thanks for watching.